It's going to be a split presentation on techno-economic modeling, which is the Meso level of the BRISKEE project. I think that's the... Okay. Could you go to the first slide, please?
Oh,
yeah. Thank you. And so it's a split presentation by me and Rainer Waltz on techno-economic modeling and macroeconomic modeling, and I'm going to start with techno-economic modeling, where the goal was actually to try to take the results from this work package on the surveys, and where we tried to find out the impacts on the implicit discount rate, and try to come up with quantifications on the impacts on energy demand in the whole European Union until 2030. And we did this by feeding the results into two models, existing models. One was the model Invert EE-Lab, and the other one is the model Forecast. Invert EE-Lab is modeling the residential sector, mainly the demand for heating and investments into retrofitting, and Forecast is modeling the uptake of efficient appliances until 2030. So we took all the results. First thing we did was we also analyzed the results from this techno-economic modeling perspective. First we looked at the results that the first work package came up with, but then we also had a second look at it and tried to see what really fits for our models, what was new for us. This was the first part. Then we implemented those findings, and we also did additional analysis on discount rates. So we tried to find out how our models are exactly affected by different discount rates. And then we defined 3 scenarios which we calculated on the basis of those implemented discount rates. And so those were the first 2. And the second or third scenario where we tried to test the impact of a policy that would address mainly the implicit discount rates of certain actors, which I will come up with. And then we did all the analysis of our results, which are fairly detailed. We're only going to present aggregated results. And the results we came up with were then fed into the macroeconomic models, which will be the second part of the presentation. Let me start with the results on heating and thermal retrofitting. The first thing, again, we did was looking at the results again, and the only picture I'm going to show you here, there are actually a lot of interesting results in the report on why people are actually retrofitting, why they decide for efficient heating systems or not. The only thing I want to show here is an analysis for all countries in the surveys on what the most important criteria for their decisions were. And what you can see is that the top 4 criteria were technical performance, energy costs, indoor comfort, and investment costs, where you already see that this is a mixture of monetary terms, but also, and which was a bit surprising also, the most important criteria was the technical performance. And then you have other criteria which are also important, but definitely less important than those ones. So economic environmental friendliness plays a role. Also financial support measures, whether they're there or not, play some role. And the other ones, increase in property value, less important, and also recommendations. So what you can see from those results, or clearly see, is that if you have a model that only takes monetary values for decision criteria, it's not going to produce any realistic results, as there are so many other criteria which are at least as important as monetary considerations. So that was the first thing. Second picture I would like to show is on the impact of discount rates in general. So this was the sensitivity analysis we did. What you can see here, I'm not going to explain the whole picture, I just wanted to show also a bit the level of detail with which we modeled this. Here, this is actually Belgium. Here you see the gross floor area of Belgium, which is about 800 million square meters for buildings. And here you see specific heat demands for different building segments, which we have implemented in the model. The more interesting stuff is here, the gray area and the blue area, which represent the buildings that are either retrofitted or where maintenance measures have been performed between 2015 and 2030. And what you can see here, if we run the model with high interest rates, about 20%, that there's most of those, or at least more than half of those buildings are actually not retrofitted. They are only going to be like regular maintenance issues are taken, but no thermal refurbishment, which would be the blue part. If we run it with 2% interest rates, almost all of those buildings would actually be retrofitted. And also more measures in general would be taken. So what you can see is that there is a really strong impact on the model from those discount rates. And the difference for 2030 is between 5 and 15% between low discount rates and high discount rates. And the other take is that if you manage to lower discount rates, it's going to have a significant impact on the whole model. Another thing you can see though is that the impact is actually pretty limited all in all still, because you can still only a few or a certain part of the buildings are actually retrofitted, because it still depends on the investment cycle and on the lifetime of the buildings. Second thing I want to show is the impact on this, of the scenario analysis. We defined 3 scenarios. One is the current policy scenario, where we assume that policies which have been implemented already now will stay in place until 2030. The second scenario was done with intensified measures, where we assume that the same measures are just intensified. That's the second scenario. And the third one is an actor-related scenario, where we assume that discount rates of low-income agents, which is a result of work package 2, where we assume that we do some policy measures, or policy measures are taken that directly address the discount rates of those low-income agents. And yeah, what are the results? What you can see here is final energy demand of the model from 2012 until 2030 for all those different scenarios. What you can see is that we expect heat demand for the European Union to decrease in all of those scenarios. So even if we stay with current policies, we expect decreases of around 70% from 2012 to 2030. But with those intensified measures, we see further decrease. And if we address those agents with low incomes, we did see effects, but they are actually not. Thanks. But they are actually not that big. Why is that? The main reason for this is that there's actually already a lot going on in the intensified scenario already, and the effect of those low-income agents was not that big. But what we did see is that the share of renewables increased significantly, which is shown in this picture. So for this agent-specific scenario, the renewable shares increased to 34% compared to those 32% in the intensified scenario. And this is because the lower discount rates of low-income agents, they fostered investment into solar thermal plants and also heat pumps instead of direct electric heating. That's the main effect we could show here. Also, investments increased significantly, which is going to be part of the second presentation as well. What were the results for appliances? Same picture again. What are the main criteria for consumers? What do they look at? They look at performance, purchase price, energy costs, but also energy labels play an important role. Less on environmental friendliness, design, and again, recommendations seem to be less important than all the other criteria. The same policy approach was taken. We had a current policy, an intensified measured policy scenario, and then one actor-related scenario, which was a bit different for the appliances. The discount rates were assumed to be very low, so 2% for all the actors. Environmental conscious consumer groups were introduced, which only bought the most efficient appliances, and subsidies for very efficient appliances were also introduced, but only for very low income groups, which was again according to the survey. What you can see here is that it is expected that energy demand for appliances is going to be much more stable than for heating, with strong decreases in energy demand for lighting, but increase in energy demand for information technologies, and also for this category new and others, which is mainly tablets, smartphones, and smaller devices. Investments in those appliances are expected to increase in all of those scenarios because it is expected there's an uptake, especially in lower income countries where the appliances are not saturated yet, so more households are going to buy them. And it was also assumed that the appliances are going to be more expensive or more efficient appliances are bought, and they are going to be more expensive, which really kind of dramatically increases the total investments in appliances around the European Union. What was surprising though was that the difference between the intensified scenario and the actor-related scenario was actually not that big, which was, or the main reason for this was that the policy introduced already assumed that efficiency standards in the intensified scenario were pretty high, and then the appliances that were even more efficient would have been so costly that all those subsidies and all the measures and reduced discount rates they were not high enough, the effect was not high enough to convince consumers to even go for more efficient technologies. I would skip the conclusions and we would directly go into the macroeconomic analysis, and then I would suggest to talk about these conclusions in the discussion part.
Yes, thank you, Michael. I'm Rainer Walz from Fraunhofer ISI, one of two persons, the other being Matthias Pfaff, who performed the macroeconomic work. Now, today we started with Joachim, the micro guy, so to speak, Michael, the Meso guy, and somehow what I'm here is I'm the macro guy. Now, why do we have one joint presentation? Basically, our specific approach is that we use the results from the bottom-up energy models, which you just saw here, and we put them into the macroeconomic analysis. Now, that slide, I think, is important to understand. If we do some macroeconomic analysis, what do we actually have to look at? Why are there actually macroeconomic effects from increased energy efficiency? Well, first of all, if you invest in more energy efficient appliances, you have a positive impulse. Demand for these appliances is increasing, and that means that production and employment in these sectors, but also in the upstream sectors which produce inputs into, for example, producing energy efficient dishwashers increases. Also, the producers of these technologies, they have increased chances, they upgrade their products, and they have increased chances on the export markets. However, you also have negative impulses. You consume less energy. Very good thing if you think in terms of climate change. But of course, for the companies supplying energy, it's a reduction in demand, a reduction in employment, and also a reduction for the upstream sectors like refineries, supplying mineral oil to households. Now, I think these two effects, these two mechanisms, they are pretty obvious. The third one is a little bit more difficult, a little bit more typical macroeconomic. What happens if an economy is producing as much as it can? It is at the production frontier, that's the term economists are using, and suddenly there is an additional demand. Well, obviously, some other demand has to give way. There is a compensation. That is one assumption, more conservative assumption, which we used. Basically, it means if the positive impulse is higher than the negative impulse, there must be some compensation, and that compensation basically is that there is a reduction in consumption for other goods. It is conservative because there's a huge debate within economics if there are specific conditions which are called Keynesian unemployment conditions. Perhaps there's nothing like such a negative compensating impulse. However, the majority of economists would argue in the very long run, maybe not in the last 5 years, but in the very long run, we are more likely perhaps in such a situation. So we were conservative, you know, we said, well, let's really not overestimate the positive impulses, let's be conservative here. What also happens is when these typically induced macroeconomic effects, you have when changes in production, that again means changes in income of the people working in these sectors, and again a second round effects, multiplier effects. And all that leads also to changes in the structural composition of the economy. You have changes that some sectors grow, other sectors decrease. And that also means that you have changes in the overall labor intensity of an economy because the labor intensity in each sector is different. And you have also changes in the overall imports because some sectors import more than others. Well, clearly, if you think that the energy sectors will be the ones which will lose demand, and energy, especially in the heating sector, a lot of energy in Europe is important. Clearly, it can be expected that the change in overall import will be in a way that Europe will import less if you increase energy efficiency. Now, what did we do? We used the results from the Meso-economic analysis and basically put together these positive and negative impulses. The positive impulses we increase in investments, and the negative impulses, the decrease in energy demand, plus these conservative assumptions that there is also a compensating effect with regard to consumption. Now, we put that all into our economic model. The results coming here from the Meso-economic energy system models, basically balancing the different impulses, putting them into the sectorial part of our macroeconomic model, putting that into the macroeconomic core where the income multiplier effects are calculated. That feeds back, and basically that kind of model is then able to account for all of these different kinds of mechanisms. Now, what are the results? Again, we are looking here only at differences of the two last scenarios, the increased efficiency scenario, D2, in the slide here, and the actor-specific scenario, the D3 scenario here. If we put all of these impulses of the increased energy efficiency in these scenarios into our macroeconomic model, the results are that on average in each year the GDP in Europe is a little bit higher, about 0.1%, a little bit above that for the actor-specific scenario, which has a higher degree of energy efficiency. The employment also increases, but significantly less than in percentage, in relative percentages compared to the business as usual scenario, and where the increase is significantly less. Basically, the same slide, it shows the development over time of these two variables, GDP and employment. Now, not that much of change on the aggregate level. However, if we look what's going on the sectoral level, we see the winners and the losers of such a strategy. The losers, clearly, the energy sector related on the side of energy and mining production. The winners, clearly, the electronic sector, energy efficient appliances on the one hand, construction on the other with insulation. Also, among the losing sectors, the service sectors, and that has to be interpreted with regard to that picture. The service sector, a lot of the consumption which is compensating impulse, a lot of that consumption is going into the service sector, and therefore the service sector is here negative. If we look at the country level, what do we see here with regard to GDP changes? Almost all countries showing also an increase in GDP. Only exception is where Spain, a specific situation also with regard to the impulses coming out of the Meso-economic modeling. If you look at employment, the situation looks a little bit different. Some additional countries with some decrease in employment, especially in Eastern Europe, Bulgaria, you see here, Poland. Even though these countries have a rather higher increase in GDP. Well, what is the reason behind that? In that countries we see that the sectors will benefit which are more manufacturing related, which have a less labor intensity but a higher value added share compared to the service sector. So we see that these sectoral shifts basically leads that in these countries you have to work less to get more, so to speak. Well, what are the interpretation of the results here? First of all, there are positive effects, and we think these positive effects are robust. They rather show the lower limit of positive effects. Why? On the one hand, these conservative assumptions I already mentioned, and on the other hand, a second effect in the modeling, basically there is a different time path of the positive and the negative effects. The negative effects basically they occur all until the year 2030 in the time horizon of the scenarios. However, the positive effects continue. If you invest in 2030, you have to spend the investment in that year, but the energy savings will occur for 10, 15 years. So a second reason for that. The effects on GDP, somewhat stronger than on employment, I already explained that. And the country differences, they can be explained by different structure of impulses for country, differences in labor intensity, import intensity of value chains. It also depends, are you then a country actually producing energy efficient appliances or not, and different structural composition. Now, last slide, don't worry, I'm not explaining the complicated figure here, so concentrate on the left-hand side, perhaps a little bit looking into the future, outlook of research, what might be very interesting questions, what are we actually neglecting in our research. One question perhaps, if we think of the micro level of the internal discount rate, on the factors affecting internal discount rate, perhaps also on the changes that might be there. One question would be, how do these changes perhaps relate also to consumption behavior in other good sectors? Is there perhaps then an spillover on macroeconomic consumption behavior which would change actually the economic model? And the second question, the second issue, what is about feedbacks from macroeconomic effects to environmental behavior? We know a lot what environmental psychologists tell us, that there is an adjustment depending on the outcome of behavior on future behaviors, what these environmental psychologists tell us with this little feedback. Here's, if you look at norm activation theories or theory of plant behavior. However, I think in the future we also have to look how this framework is also affected if you look how people perceive the economic effects of that kind of behavior, that also perhaps changes perceived behavioral control in the language of environmental psychologists. So perhaps opening up a new avenue also of research, which might be very interesting in the future. Thank you very much, and now we are looking to your questions.
Thank you very much, Edwin Cornelis of Tractable NG. And my question was, and still remains, whether this analysis is also conducted for other sectors rather than the household sector. So, and if not, for instance, the industry, would industry behave much more different than within the residential sector? And what's your opinion on that?
Well, on the so.
Can you please use the microphone?
Sorry.
For the
So in this case, it was only done for the residential sector, but it would be both for the forecast model as well as for the inward model possible to do the same thing for the service sector. And in terms of differences, I would say that at least for the building and heating side, that it would change very much in the sense that there would be much more weight on economic parameters, where in the inward model, only like 30 to 40% of the decision is really based on monetary terms. And in the industry, of course, that would be completely different. And the other difference is that we, at least we assume that the consumer looks at like 10 years, 15 years ahead. And of course, in the industry, that would also be not true. So there would be a big difference.
Might be an interesting question also to the micro guy, of course. As far as I know, I would argue it might also depend on which sectors of industry you are looking at rather large companies compared to small companies. With regard to the macroeconomic effects, it depends then a lot on the ratio, how much of investment compared to how quick you have the energy recovery. But the general idea would be the same, I guess.
Roland Jepsel from the EIB. Question to Mr. Hartwig. You listed the top 4 criteria why people would choose or invest in energy efficiency, retrofits, and windows and the likes. And you had there, the first one was technical performance. Mm-hmm. And I was just trying to understand what is the difference between the technical performance and energy costs. Mm-hmm. Is it just about the standards? And how was the connect between environmental friendliness And again, energy costs, aka climate aspects.
Well, maybe also Joachim Schleich can tell us something about it. The technical performance really relates to whether the system works. So the heating system, it should not break. The insulation should not cause any troubles, and that's basically it. And for environmental friendliness, Joachim, you already mentioned that there was this scale used where people were asked whether they consider themselves to be environmentally friendly.
Yes, that's correct. There was a scale used, but this one was a different item. We asked respondents for the different type of investments. How important on a scale from 1 to 5 was this, and this item? And these were the items: technology, performance, energy costs, and so on. So this is slightly different from what I was talking about. But otherwise, yeah, I fully agree with, or I support what you said before so far.
I don't know if it's a question. It's an observation looking at that figure up there. It's one observation is that people in Sweden are not using high value in scores. There's nobody going in the high end. And if you go to Italy and Romania, they give very high scores. Is that a problem in a survey like that?
If you look into the report, we have the same figure, but divided by the mean values of the total scores they gave to all the answers. And it's completely correct that the Swedes, they in general give less scores or lower scores, but the figure itself and what the figure says, it does not really change. The only thing is that you just don't see significant country differences. But in terms of the ranks, what the most important criteria are, it's the same picture.
It's more, again, an observation to see if I understood correctly from the presentation of the macro results. So basically, the impacts on the main macroeconomic indicators basically show what will happen if we had two scenarios, one with a population with a certain level of discount rates, and another one with we have a world or a population with people with lower discount rates, which is basically similar to say what will happen to our economy if we'll have more energy efficiency, basically. But what's behind, what drives more efficiency in your analysis is basically a different attitude and behavior of people towards efficiency or decisions in efficiency.
The observation is correct, and I think it is also an important observation to have that, because if we think of also on the policy side, and perhaps Wolfgang will come to that very soon, if we think of a policy side, what can we do to enhance energy efficiency? What does it mean perhaps with regard to supporting the lowering of the internal discount rate with certain programs? The question always arises, so what is the effect on that, not only with regard to energy efficiency, but also in the economy? And so for that kind of debate, the results here help that they show you well where is probably also not a big, but a rather positive effect as well.
Thank you. I'm working in the economic department, so I am surrounded by economists, of course. And they are pure economists. And when I see that graph, I was interested by the conclusion. And the conclusion that your colleague mentioned, he says that we cannot model taking into account only monetary terms. Mm-hmm. What do they answer to that question? Technical performance, something that you can monitorize through the risk. For example, I consider that heat pumps are more risky than a gas condensing boiler. So I will put another discount rate. So in fact, all the criteria you mentioned can be monitorized for a pure economist. Mm-hmm. I always answer to that energy efficiency investment is more complex and complicated than only price. So I fully agree with your conclusion, but their answer he say we can monetize everything.
Yeah. So I would, if I can answer to this, I would maybe in general agree that you could do this, but then you would have to split up a lot your investing agents, and then you would have to transform all those parameters into discount rates, and then maybe that's true. So theoretically, I would say yes, it might be possible. But yeah, the other thing is, or another conclusion out of this is that you also cannot compare discount rates of different models if you don't look into the decision algorithm. Like we have discount rates implemented for the decision, which are somewhere between, depending on the country and agent, between 2 and 15. But we add all the other barriers as other components in our decision criteria, which would then in fact translate into much different and much higher implicit discount rates of the model. So you also have to be very careful of the meaning.
Perhaps one quick remark, because there's a fundamental issue behind it. How do we perform analysis with regard to that kind? Now, in addition to working at Fraunhofer ISI, I'm also part of an economic department at the KIT, Karlsruhe Institute of Technology, where I have all of these economic professors around me. My conclusion is, if we study that kind of effects, we really have to perform a very interdisciplinary approach, and basically that means we have to look, does our analysis, perhaps our micro-analysis, is it also in line with what the environmental psychologists are telling us? Is my macroeconomic model, how can I open it up? Not every macroeconomic model actually is able to differentiate different technologies. So what is the requirement on the macroeconomic model? How can I translate the results from the analysis of Michael? How can we translate it in what my model actually can distinguish? And you only can do that if you really have a deep interdisciplinary understanding. So I think that's perhaps another key methodological outcome of that kind of debate.